All right. Good morning, everybody, or good afternoon, depending on the part of the country that you're calling in from. Welcome to our webinar and our partnership announcement with between NILEX Civil Environmental Group and Contech Engineered Solutions. My name is Trevor Dirksen. I'm the President and CEO of NILEX Civil Environmental, and I'd like to welcome everybody to this webinar. NILEX has been involved in working with the ArmorFlex product for over 15 years. But today we're happy to announce a new partnership directly with Contech Engineered Solutions to help further promote this product throughout all of Canada. I'd like to welcome all of the site and project owners, engineers, and contractors. There are several dozen of each of you that are on this webinar, and so we're going to turn it over to a couple individuals from Contech, followed by Vice President from NILEX to conclude at the end. The individuals from Contech are Dan Priest, who's the General Manager of Contech, as well as Barry King, who's the ArmorTech Eastern US and Canadian Area Manager. So welcome, Dan and Barry. Over to you, Dan.
Thank you, Trevor. Good morning, good afternoon, everyone. As Trevor said, I'm Dan Priest, the General Manager of Contech's Hard Armor Erosion Control Division. For those not familiar with Contech, we're a site civil infrastructure products company headquartered in Cincinnati, Ohio. We specialize in stormwater and sanitary sewer piping products, as well as stormwater treatment and management solutions, prefabricated steel, concrete, and aluminum bridge structures, and the hard armor erosion control solutions that we'll be discussing today. Contech is extremely excited to be partnering with NILEX and allowing them to continue to bring the ArmorTech products to market for you. Their expertise and experience in your marketplace is second to none. NILEX and Contech have similar technical marketing strategies, which provide support from the preliminary front-end design and technical drawings through final design and bidding and installation guidance and site issue resolution. It's the goal of both of our companies to provide you not with just a product, but to be a true partner during every stage of your project. And we hope that that's what you'll take away from this presentation. At this time, I'd like to turn it over to Mr. Barry King, Contech's Eastern US and Canadian ArmorTech Area Manager. Thank you. Barry?
Thank you, Dan. Thank you, Trevor. Greatly appreciate the opportunity to present today. I will jump right into it. Yeah, I'm as they mentioned, I'm located in Cincinnati, Ohio, and again, greatly excited to support the Canadian team up there and bring whatever necessary experience and knowledge I can to an already very talented group. So I'll get right into it. I'll start with ArmorFlex articulated concrete blocks. We'll start with this product and follow up with another product after this, after a few project profiles local to Canada. And so I'll jump right into the ACBs. They were developed in 1970, around the 70s in the US. ArmorFlex, is an articulated concrete block mat. It's made of a flexible matrix of concrete blocks with uniform size and shape. Think the same D50 for each stone. The blocks have specific hydraulic capacities and are laced longitudinally with revetment cables to provide ease of handling and mass installation. Be efficient with your laydown. And just to get into a little bit of the legacy and the success of the product line and the products we're going to be speaking about today, Contech has been in the business for over 100 years, and ArmorTech has a rich history of more than 35 years in the industry, leading development of hard armor. And when I say that, you can look here at the timeline from the late 70s. Ends here on 2013, but even today we are continuing to further what these products can do and to be useful to engineers and contractors alike. For ArmorFlex, it's really quite simple. I mean, you can see there in the top left diagram, it's a flexible interlocking matrix of concrete blocks, uniform shape and size and weight. Again, think D50, same size for every stone in the matrix, cabled for quick installation, and they're assigned specific hydraulic capacities via testing, and we'll get into that, the ASTM portion of that a little later. Different thicknesses, 4 3/4, 6 inch, 7.5, 8.5, and 3 different footprints to really equate to just about every flow regime that we've seen, and offering just whatever least cost solution for the project at hand, and while still accommodating factor of safety and necessary redundancies. Scour protection is one good application for ACBs. It can be used as a full invert, partial invert, i.e. a distance away from the footer or abutment. When used in a full invert protection, ArmorFlex can often eliminate the need for deep foundations. Is my audio coming in okay?
No, Barry, there's an echo in your audio.
Okay. Yeah, I heard that. That was a first. Let's see how this continues. Okay, and then shore protection. Here's another good example of the use for ACBs. You can see there on the left photo of the finished open cell, and really the scope of what these projects can address in a coastal environment. When we look at those, we're talking about wave attack, period of the wave, height of the wave, embankment, and really employing those necessary factor of safety and sizing methodologies currently accepted. Flood control is another big area where these systems can offer benefit as the climate continues to change and urbanization continues to add additional water to the watershed. Flooding needs, they need to be directed in a manner that convey the flows without erosive failures. And ArmorFlex is a very good tool for that. Channel lining, in this case, channel lining in conjunction with pier scour, it makes a great lining system. The open cell blocks allow for vegetation. You can see that in these before and after photos. And what you're looking for is something that can disappear with the natural grasses, but know that you have the robustness of a system when the big design event comes through. Primary spillways, they see repetitive, high velocity, high shear flows, right? And they need to be armored with a system that can prevent erosion and withstand that high tractive force and high overturning velocities. Right here, you can see this is a power plant discharge channel into riverine environment, very high velocities, activated on a daily basis, 4 years. The product and the system is working without any issues. And then if you get into another spillway environment, in this case, there's many impoundments that are now undersized based on the growing watersheds, as alluded to before. And so in order to provide protection against climate change and increased storm events, these emergency spillways need to be constructed to provide relief to the system. And here, as you can see, you have on the left-hand picture, just finished with construction. You're just looking for your seed to come in. And then on the right, the picture of the vegetation taking hold. This is 8 months after final construction. And so really, again, the spillway blends into this environment while still providing that robustness that you need when the event occurs. Dam overtopping protection, another great solution for these systems. And again, you can see the degree of vegetation that can be achieved. Not required. It is a veneer for aesthetics. But it is often used in park environments where you want the hard armor to disappear. It works very well there. Downshoots. In this case, a very large downshoot, as you can see, a very long alignment. The system's ability to withstand the high velocity flows associated with applications like this, very, very, very well proven. Science is science, hydraulics is hydraulics. Overturning moments are overturning moments. You size for the hydraulics that you anticipate and accommodate for factor of safety, just as with any revetment system. Outlets and outfalls are another very good application. You'll see high scour directly downstream of outlets. In this case, you can see you have 5 barrels discharging out into the splash pad. These systems are very, very good at accommodating transitions, and so you want that transition and those forces associated with going from one system to another to be armored efficiently. These provide a great solution for that. And then, of course, utility and pipeline protection. This is something that we see quite often. In this case, it is a telecommunications cable in a marine environment, and really you are providing not only counteracting buoyant forces. With some of these pipelines are buoyant, and so we work on that, as well as potential impacts from anchors, fishing equipment, and other marine devices or issues that are present in a bay or a riverine environment. Low water crossings. Sometimes a bridge doesn't really work well, and in this case, boat ramps are kind of the same. You're trying to get to the water's edge while maintaining a good tractive force. The open cells of the block really provide a great purchase for the tires of vehicles. And if you're looking for something larger vehicle, yachts or something on a larger scale, really you just want to look into the wheel loads and the bearing pressure of the soil there. Possible improvement might be needed, but a very common application for these systems. And here we go. Yeah, low water crossings. This is where, not necessarily a bridge is going to make sense, right? And so in these cases, a flexible roadway, so to speak, with hydraulic capacities for the flowing water really makes a nice, easy install, and something that'll last for years to come. And so those were a little bit of the ArmorFlex system. You saw some of the applications. I'll get into a little bit of the meat and potatoes of the design and testing. And so I'll just start right away there. You're going to hear a lot of compliance testing and adhering to proven standards. I'll go over that as necessary here. And there's a lot to cover, but we've condensed it for this presentation. So in testing, ASTM compliance, probably the most important aspect of the ACB system internationally. ASTM is an entity that it deals on an international scale. And so when these systems were originated, the Federal Highway Administration of the US, they saw benefit with these systems. They worked on a research study back in the mid to late 80s, and they really found out a lot of good information. The problem is when further testing was done, it was found that FHWA work was a little bit lacking. And so what happened is ASTM International put their arms around this very viable product and system to be used out there for the engineers. They realized that it had benefit for the civil engineering community out there. And so they really wanted to get this right. They tailor-made ASTM testing compliance standards, how to analyze that data, and all the way down to how you construct these systems in the field. So a really very robust and very detailed way of looking at these systems, not only from a engineering point of view, but also from a manufacturing point of view, as well as an installation point of view. So to talk a little bit about those, the first we start with is my favorite, being an engineer. I like testing. And so ASTM D7277, that is the performance testing setup. So how you physically construct your test. You can build it at this lab in the US, you can build it in the Delft laboratories in the Netherlands. Wherever you can accommodate the discharge, you can build according to ASTM D7277. The actual way to construct and measure the test. And then once you go through that actual test, you're going to take that data and run it through ASTM D7276, which that takes all the mystery out of the testing. There's one way to interpret the data. It's very, very well defined, very hard to screw up. And so essentially, you are going to, whoever has the data, whoever's done the testing, it can be defined and analyzed one way per ASTM. And so all systems are on equal footing when it comes to the analysis. And what comes out of that eventually is this is an example of our testing program, 2 of many pages of a long testing document. But you're looking for the capacities, you're looking for the velocity and the shear, the bed shear that these systems can handle. And from that's when we go into design. You can take the systems, run them through the design methodology and design for the actual projects out there in the world. And what methodology would we use? Factor of safety. What you're looking at here, this is NCMA's version of the factor of safety method. And why we're showing you this is the most condensed, most understandable version out there. It is concurrent with everything in the States, all with ASTM, testing compliance. It's all the references are there. This is just the best way, most straightforward way to run the factor of safety for the masses. It's available on their website, easily downloaded, directions, how to size these systems. It's all right there. But here at Contech, and as we support NILEX, this is the methodology that is accepted by international community for factor of safety for the systems. So let's talk about velocity. I mentioned that before. A little bit about permissible velocity ranges. This table here, this gives you an idea of what is out there for the designer. From bare soil up to ACBs, very large range of velocities that you can see. If you look there at riprap, around 12 feet per second, that's where we kind of see that limiting. And there's a few reasons for that we won't get into, but there's a whole lot of tools there in the toolbox, with ACBs being a permanent solution with the higher echelon of velocity, permissible velocity ranges. And then looking at comparing with riprap, and what you'll get from me is I'm not here to say riprap is a bad thing. It is a tool in the toolbox, but what we need to understand are limitations of our tools. And it's well proven that riprap as designed was formulated, all the methods out there, you pick it, Army Corps, Caltrans, there's literally hundreds of riprap methodologies. And what they found out is around 12 or 15 feet per second, things get a little dicey for riprap. And there's some reasoning on that about the bench scale testing versus full scale testing. A lot of things go into that, but I think we've all seen that around that 15 to 20 feet per second, rock tends to move. And so this depiction is kind of a velocity-based comparison of where we would play. And so if you look at the 21 feet per second there in the middle, truly we can handle that with a 4 3/4 inch tapered system or an 8.5 inch non-tapered system. In the riprap world, you would be looking at a 64 inch D30 for that. And so a very deep section, that's more excavation, that's more material brought in, knowing that rock does tend to move at lower velocities. So just a little bit about how it would compare. I think about excavation. I think about the thickness of veneer to handle the flows that aren't changing. So just a good comparison about how they stack up. Manufacturing and installation of ArmorFlex. Again, a standard, an ASTM standard for these procedures. So when you're talking about manufacturing, you're talking about D6684. And I understand that that's a lot of Ds and a lot of numbers, but the point is that this should really give designers and owners confidence that these systems are well vetted, from the hydraulic testing interpretation of that testing, to the manufacturing, the material specifications, freeze thaw, how you sample that material, the quality assurance, that is also in an ASTM standard. And so then you get into the installation. There is, and it's nothing earth-shattering science-wise, but it's dirt work, and it speaks to the standard subgrade preparation. It talks about filter installation and how these systems go in efficiently in the field for the contractor. So all these standards that we've been talking about, that I've been going on and on about, they are to provide confidence. They are well vetted. There is nothing hidden here on how they are placed, how they are analyzed, and how they are manufactured. It is all right there, open to the public. This is what this system is. And so with those confidence markers, I'll call them, you should really have a good idea of how you can service your project, relying on such thorough criteria that has been done behind the systems, right? So talking about a couple project profiles, I wanted to get into that a little bit, and picking some local Canadian projects. Right here, you'll see Highfield Reservoir near Herbert, Saskatchewan. Yeah, Herbert is the closest near it, but this is a fairly remote site, and the design challenges. It was a flood control system. They had various levels of protection depending on where you were in the site. Okay, you needed very, very, very light protection in some places, and maybe much more robust protection in other places where you had steep bed slopes. And so, for our portion, for Nilex's portion in this project, the ArmorFlex tapered system was installed in the main chute channels, and really where the flow would be changing direction outside of those chute channels, and the support that we Nilex and that Contec always provides are specifications to the designers. We work through the design on the upfront as needed to tailor make it for the project. Contract drawings, we have detailed ad nauseum. We can tailor make those to the project. We have standard details, obviously. And then, of course, on-site installation, everything looks great on paper, but you have to build it, and we're going to be right there with you. So that's something that we very much pride ourselves on. The outcome, wrapping all that in, efficient installation, and then stressing terminations and transitions to other systems. In the Highfield project, there was a lot going on. You had transitions from ACB to TRMs to high performance TRMs to riprap. How does that happen? What are the details needed for that? So to check all those boxes, to make sure the contractor knows what to do, can do it efficiently, is something that we really pride ourselves on. So this is the Highfield Reservoir in Saskatchewan. Another good project. I really liked this when it was shared with us. This is a channel lining / bridge scour, I will say, in the Exshall, Alberta is where it was located. And accommodating projects with critical portions of infrastructure are common challenges with Contec and Nilex. I mean, we attack those problems with designers. I mean, that's something that we pride ourselves in doing. Having an appreciation of staging, order of construction, the right-of-way constraints, all those come into play, and we like being on the front end of that because at the end it's gonna mean a successful project. The more you know, the more successful you're gonna be at executing the build. And so one main highlight of this project in particular was the ArmorFlex tapered system, and so you really needed the system have the ability to convey the water efficiently. And that's what was done here. You can see the railroad crossing with the low head. So maximizing that space was paramount. That was a big design criteria, big part of the governing design for the project, to get that large drainage area discharged efficiently through this conduit while maintaining the railroad crossing, critical infrastructure to the area. And it went off without a hitch. Very, very good project. So I'll move on from that and something a little less maybe obtrusive, a little bit more recreational, shall we say. Banff Legacy Trail flood repairs. In 2013, I'm sure everyone on the call is aware of all the flooding that had happened in that area. Well publicized. We heard about it down here. I have family in Ontario. They were telling me about it. And so severe damage in that June event. And so the idea was to rebuild the trailway, incorporating an armoring system, and really understanding that, hey, this can happen again, and what do we need to do for this trailway to fit this budget and make sure that we are actually successful when it does happen again. So as you can see there, the left-hand picture, you see the embankment of the trail, the ACBs, ArmorFlex material getting set down on that embankment, and just providing, as that overflows, when and if that overflows or is attacked by a flood event, you know that road, that trail is going to withstand that. You know, these systems were designed for the flow coming through there, so we know with good with confidence that this system is accommodating for that design discharge through the area. And additionally to that, we wanted to ensure that the trail it meshed in with the surrounding park-like scenery, right? And so on the right-hand picture, very good loamy topsoil was backfilled on top of the system afterwards, and then you can see some natural riprap stone down at the toe to kind of blend all that together as it transitions to more natural surroundings. But in that planted area, that topsoil, there were native grasses planted and native flowers to beautify that area, knowing that you were going to be armored when that flood happened again. So very successful project, a good blend of aesthetics and good engineering on this. So yes, I'll transition real quickly to Ajax concrete armoring units. You might not be as familiar with these up there in Canada, but something that has been used in the States, and I know it's been used to good effect up in your neck of the woods as well. So I'll get right into this. Very robust unit, interlocking, high stability. They come on pallets. They're shipped on pallets. They're assembled in the field and placed in either hand placing or bundled. That sometimes sounds a little scary to contractors, but really the hand placing and bundles, you're looking at 1,000 to 1,100 units a day, about 1,100 square foot a day with a 2 to 3 man crew. So much more efficient in placing than, and I always laugh when the contractors are surprised on how quick they go down. But engineering wise, they're very rough layer. Full scale testing were done on these. 2 foot, 4 foot, 6 foot, 8 foot, and 10 foot are available. We mostly deal with the 2 and the 4 foot. Pier scour protection is a very good device, or a very good application for this device. If you can imagine, very rough system, providing that, breaking up that flow around a pier in a flashing environment can provide very, very good benefit. Energy dissipation. This is downstream of a flood control device for farmland. And right here at the outlet of this, you can see what's happening. You get the boil of the hydraulic jump on top of the 48-inch Ajax units immediately downstream of the discharge. And then you can look at toe stabilization. This is, if anyone has seen a slope fail, they know that it's not really the slope just all of a sudden failing. It's lost its toe. The toe has been eaten away and eroded, and eventually that embankment gets so steep that it caves in, and then the process starts again. So in this case, toe stabilization with these units, a very, very good application, provides something at the toe that very difficult to dislodge, very difficult to move these particles and flow. And so the upslope behind them benefit from that. And then drop structures. They've been used quite often for dissipating, on downstream of outlets. You have some natural environment. You really want to take the energy out of that flow, and Ajax does a very good job at that. As with breakwaters are another good application. You can see here the stillness of the water on the right versus the left on that picture there. These are 6-foot units here. Coastal wave protection, that's another use that we see for these. They work quite well. So you can see them being placed there on the breakwater in a random fashion. You can also place them in a uniform fashion. And then on testing, I love a good test. All engineers do, especially if they're designing with these systems. These have been tested throughout the world. Here you can see a wave attack test. This is an at-scale model in Australia at the Manly laboratory. And then further testing, US, in the US, we've done structural testing at Auburn, impact testing at the same entity, stability testing, wave attack testing, that's been done in both Australia and in other places. Pier scour, understanding how that phenomenon works and where to place those systems, and developing a factor of safety methodology for the Ajax. Design velocity and design shear, those are really the only two overturning moments or tractive forces acting on any kind of veneer. So that's what you're going to design for Ajax systems. So getting into the design, a free body diagram is worth 1,000 words. And really, you can see the forces there. You have your lift force, your impact force, your gravitational force, and the pebble, in this case, your Ajax, it wants to rotate in the flow, right? That is what failure means in a hydraulic scenario, sliding or rotational failure. And just inherently in your gut and just knowing the shape of these jacks, they are inherently stable and permeable, so very difficult to move. They're very, when you're dealing with the researcher and they fail to move a full-size unit, a micron and a full flow of the flume, they don't like that too much. We like that because the capacity of the hydraulics are such that it's really valuable to the hydraulic community. But testing laboratory people, they like to fail units. And so they haven't failed this one yet, but they're still trying. It has worked so well and it showed so much promise. The FHWA, National Highway Institute, they actually brought the Ajax unit into their bridge scour and stream instability countermeasures. Really where the Ajax shine is the bridge scour in this document. Very detailed way to look at a concrete armoring unit, in this case an Ajax, how it's designed, what the footprint is around the piers, what the approach velocity, everything you need to know about bridge scour and limits of protection is included in that document. So we feel very lucky to be included in that, and knowing that it pained the federal government probably to include us. It is, Ajax is a trademark. It's not doesn't have any patents on it. It's just a trademark. So they they saw the benefit to include it in the federal document for the infrastructure in the states. It spoke volumes about what they think and how it's being used and the success that they're seeing out there in the field. So project profiles, a few about the Ajax. And these are in the States, some of the larger scales that we're currently working on. This project, US 95 Clearwater Bridge in Idaho, the bridge was top 10 of the most scour critical bridges in the state. And if you know Idaho, if you know the West, I mean, very, very cognizant of their water quality, very cognizant of outdoor recreation, things like that, knowing that they had a problem with a multi-span bridge that was a big deal. And so for the solution, 24-inch Ajax around the piers. You can see in the right-hand picture there, the submerged. This is the pier closest to the bank. They included this protection throughout the piers across the entire span of the Green River, or the Clearwater River rather. Our support, specifications, detailed contract drawings, and of course the on-site installation assistant, not only for the Idaho DOT, but really for the contractor building the project, letting them know what they can do, how they can do it, ensuring that value engineering was sound, and everything came out the way the owner expected it and the way that we would expect it. So very good project. It's been written up many times here in the States as a success. They continue to monitor that for the scour, and I think it's been about 10 years it's been in, maybe a little longer. I'm dating myself, 15 years. But yeah, they've had no issues at all with the scour protection, and NRCS continues to monitor it to this day. This is a project currently being installed. The Mississippi, not too many rivers, much larger here in the States, but the Mississippi River, a lot of power. And they had a problem in Tennessee. The Tennessee DOT in Dyer County, 78-foot wide, 4-lane bridge. It was 7,100 feet long, multi-span, carries interstate from Mississippi to Missouri to Dyersburg, Tennessee. Anyway, over the years, extensive scouring of up to 20 feet for a lot of these bridge bents. And bedrock was located 2,700 feet below those, and so they were on pier foundations, on shafts with pile caps. So, you know, to have that kind of scour around these foundations was very alarming. They needed to fix their problem, and what they ended up approving and actually installing, which is continuing to this day, are 48-inch Ajax bundles. You can see on the right picture there how they oriented those together. They actually massed 48-inch units in a bundle, and they would place in mass. And it's just another example of the contractor teaching us how to be efficient, right? The idea is to get the material on the bed to counteract the scour. They showed us how to do it the best way, getting the most down at one time, maximizing their efforts for the time allotted for the project. To date, it has been very successful. They are ahead of schedule for this project. So that was a lot. I've been going for about 50 minutes, and that has been a lot. So I'll let that sink in a little bit on while I go through this slide. And if anything that you've seen in the past in the presentation there, I mean, one thing that you can understand is that the design is important to us. We want to know what is being done. We want to help if we can. We want to raise red flags. That is, we truly see ourselves as partners in the process, and we know our limitations. And so that's important, especially when you're dealing with water. Specifications, we help engineers develop the efficient solution, right? And so whether that's calculations, helping on a performance specification for the site, addressing hydraulics, site-specific drawings, submittal packages, things like that. That's what we bring to the table. Permitting, we make sure that all the recommendations are approved locally. Product approval, regulatory, stakeholder engagement. We play in those arenas as well, and we can help usher out success by partnering, being a good partner in that arena as well. And then, of course, you've heard me go on and on about the projects here. Installation, I think, is where we shine. It is commonly overlooked, but it needs to get built. It needs to get built correctly. Projects need to adhere to the plans, knowing that things change in the field, and that's where to have a good partner to condense that time lost, to have the correct answers for the system as they're building it, and minimizing those lag times that can really impact a budget over time. No project is perfect. And so installation, you need to be there. You need to know what you're talking about and offer that knowledge to both the engineer and the owner, and most importantly, the contractor as they're constructing. So a few other photos here, and my time with you is ended, and I hope I put forth some excitement there for the group. I'm excited to be part of the NILEX organization and working with those kind of folks and very adept folks at what the challenges are there for the region. So on that note, I'm going to turn it over to Gertch. Gertch, you can take over now. And again, thank you all for the time.
Thank you, Barry. My name is Gertch Sakon with NILEX. It's great to see so many familiar names in attendance here. Hope everyone's doing well. We have partnered with the clients over the past 44 years, helping them find ways to do it better in the civil environmental sector. And we're very proud of that. I wanted to leave you with the following thoughts, in number one, technical certainty. Barry discussed some of the standards, the ASTM standards, the design methodology from NCMA. These are all in place to validate the performance of an ACB system, in this case, ArmorFlex, right? And where we're looking for a predictable performance and the consequences of failure are high, we have some infrastructure that's at risk. We as designers need to be assured that there are some independent data to support the performance of the product. In addition, around the technical certainty, these blocks, these ArmorFlex units are manufactured to very tight tolerances per the ASTM standards that were discussed earlier. In regards to costs, we'd be happy to provide a cost analysis, both capital cost and life cycle cost analysis for a given project. So please do not hesitate to reach out. Barry showed some examples where we demonstrated our footprint, the footprint of the ArmorFlex units versus riprap. We have a significantly smaller footprint than a traditional conventional riprap material. So we can provide some carbon footprint reductions, and we can calculate those and itemize those for you on a project. The riprap, there are several regions throughout Canada where riprap is becoming scarce, and the quality of the riprap, the durability of the riprap, the size of the riprap is becoming scarce and challenging to find. And I think we know some of the additional challenges around layer thicknesses associated with riprap. So we can definitely provide some benefits over those conventional materials. Next slide, Barry. What I'd like to do now is, first of all, thank Barry and Dan for the presentation, and thank them for the partnership with NILEX here. Looking forward to some great success with their collective partnership. And I'd like to open it up to some questions, please. You can post some questions in the chat line if you like, or you can unmute yourself and put some questions forward. Doesn't look, I don't see any questions coming through.
Hi, can you hear me?
Yes, yes.
Okay, this is Shamsul.
Hi, Shamsul.
Hi. Do you have any lab experiment for the wave actions?
Yeah, I will
And
I'm Barry or Dan. Wave action lab testing is a question,
yeah,
Barry.
Yeah, and I'm looking for the KD value from the lab testing.
Yeah.
And what is the maximum slope for the shoreline protection you can consider for the ArmorFlex?
Okay. I can take that one. So, yeah, when you said KD or I suspect you were using the Hudson method
Yeah,
for sizing. And so for these systems, and we can work in Hudson, but extensive, you heard me mention the Delft laboratories earlier in the presentation. And so there's a method called the Pelargic method, which is instituted for ACVs. And so that was done by Christian Pelargic, and it's very similar to the Hudson method, except you're looking at a stability factor, and then there's a lot of emphasis on the actual embankment geometry. So we can probably more for this call right now. But yeah, we can discuss this if you, I mean, I'd be happy to drill down on this with you.
sure.
Very similar methodologies, but Pelargic method, that's really, because you said it, the steepness of the embankment to really wrap in the geotechnical portion of wave attack is what he brought to the table. And so how those, not only ACBs, but other revetment devices, he looked at all different types and evaluated each, and so we can talk more about those, but
Sure.
Pelargic method is the method that we use, and the most steep that I've seen in application was 1.75 to 1 was the embankment,
Okay.
and it was a 40-foot vertical embankment.
Okay. Yeah, maybe we can talk later after later, right? Yeah.
Absolutely.
Yeah.
No, that's a very good question.
We'll connect, Sham, so I'll connect you with Barry and we'll get on a call.
Sure. Thank you.
A few questions. Sorry, go ahead.
Tim Eisman from BC Hydro. Just got a question about how the product is made and distributed. Is it made at say local concrete suppliers and then supplied to ArmorFlex, or is it made locally with manufactured forms, kind of like lock blocks? Is that kind of how the process works for this product?
Right. And Dan, do you want to take that one over?
Yeah, I'll grab that. So I see a question in the chat asking about the type of concrete in the MPA as well. So I'll group these together. So both the ArmorFlex and the Ajax are manufactured from dry cast concrete, 4,000 PSI dry cast, or 27.5 megapascals. And so manufactured on the same type of equipment that makes concrete masonry units, concrete blocks. And then those units are then strung together into the mattresses. And so Nilex has a partner that they've aligned with to do manufacturing in several places in Canada, and do their own mat fabrication and conversion there into mats.
Okay, there's another question here on the chat board. What channel gradients are your ACB blocks able to handle?
I can get that one. So you heard us talk about the ASTM testing. A standard tested bed slope is 2 to 1. Okay, 2 horizontal to 1 vertical. My background is in geotechnical engineering, and just inherently, anything steeper than 2 to 1, you really got to start thinking about the global stability of that embankment and that material. You really want to put more investigation there. And of course, as you get steeper, that's going to become more and more important. But for the ACB systems, ArmorFlex system, we have armored up to 1.5 to 1 in a channel, a spillway, and then 2 to 1 for dam overtopping is we've seen that steepness, but dams are usually about 3 to 1 just because of the way they're constructed. But 2 to 1, very comfortable at that. Anything steeper than that, we're going to start asking questions about, hey, what's your global stability, and is that embankment stable just upon itself weight in a saturated condition? So 2 to 1, And anything steeper than that, we start asking questions about geotechnical stability. Hopefully that got that question answered.
Another question here from Kevin Gallant. Have you used plant restorations with dune or maram grass for coastal applications?
I know that there was yes, and so when I say yes, you said the right thing here. What we don't want to see in the ACB units is any kind of woody diameter planting. Anything that's going to grow in diameter. Think of your sidewalk. You know, everyone has that tree that grows and it breaks your sidewalk, and you call the city and they come and cut down the tree. But so think about that. That's what we don't want. And so grasses, those are good. You know, those don't affect the system like the diameter with the trees. And so the key to this is that you want to make sure that you have the appropriate topsoil. I showed some photos of very grassy final installs. Well, you know, that was done, you know, the spec was written, hey, after we're done putting the ACBs down, we're going to go with 4 to 6 inches of good topsoil. And so with this question with the dune or marram grass, that the same would be in play there. You just have to make sure your seed bed is what you would want without the blocks there. You know, the type of soil, seeding per normal. And then after you seed it, how do you grow that? You know, you're going to have to tend that a little bit to get that seed bed rooted. But once it's established, you're good to go. You know, knowing that whenever vegetation is in on these systems, revetment systems, I consider it sacrificial. So if it is an area where you do get a lot of inundation or a lot of heavy wave attack or something like that, where it's going to be wet most of the time, your expectation shouldn't be a lot of grass, because you're going to be seeing a lot of hydraulics there. But if it's something that's very seasonal and you're at the Q100 or Q500 and you know it has seen flow but not very high recurrence interval, that's where the soil is much, you know, a much better chance of staying. I guess what I'm saying there is when you're planting grass on any hard revetment, it is considered a sacrificial layer, and if the design of that comes along. So hopefully that made sense to the group.
Yeah, just to expand a little bit there on Barry's point, we've had success with lots of different grassy vegetations, especially in the coastal applications, but they vary by region and by geography. And so, you know, it's always best to consult a local horticulturist to make sure that we're getting something that's native and tolerant in the area. And with that, then we've seen success both along the Gulf Coast in Florida and Alabama, all the way up and into the New England coastline for shoreline protection using those type of seagrasses.
Yep.
Excellent. Thank you, gentlemen. Another question here from Brendan Osorio. Do you have a cost comparison per square meter between the ArmorFlex and the riprap? I think I can take that one on. Yeah, definitely. We can provide cost comparisons between ArmorFlex and equivalent size riprap. I know riprap costing varies by region and you know, and based on location of the project. So we'd be happy to provide that cost comparison if you can share the location of your project, and if you have some riprap pricing for your region. Happy to do that. Another question here from Darren Martin. Lifting devices. Are the lifting devices supplied with the product as a rental for return when completed? Also, the ties and the anchoring, are these supplied?
Yeah, as far as, and I'll take that one. So as far as the anchoring and the ties, it's important for the ArmorFlex system, and this speaks back to the ASTM testing we were talking about. Mechanical anchoring and lateral tying is not required for the ArmorFlex system. And why I say that is that we know what the system can do in a flume. with 5 foot of water flowing down it. And so that is the definition of failure. And so the anchors and any kind of lateral connection, that is outside of any of the factor of safety. Now, if you wanted to put those in, you can do that, but you just have to understand that they're designed to accommodate the hydraulics without those. So, and then on the spreader bars are commonly shipped with they're available. And I know here in the States, and maybe Kurt can talk more about it, is they're supplied with the mattresses, and then there is a rental fee on that depending on the length of time, and typically that's worked out with the contractor upon when the agreement's made. So does that make sense?
Yeah, thank you, Barry.
Yep.
Question from Kevin Glant. Do you have a design or how-to installation video channel? YouTube link. On installation, do we have an installation video on YouTube?
There are some contractors who have posted their installs up on YouTube. We don't have Contech doesn't have anything official for ArmorTech on there, but appreciate the thought and the idea, and we'll be getting with our marketing department to see if we can't make something happen.
We do have
we've got a very thorough installation guide.
Yeah.
That we can definitely share with you, Kevin, in the interim, and also some photographs of the construction installation sequence. Be happy to do that. Okay, I think I've got all the chat questions. I'll open it up to any, good feedback here. Thank you, Susan. Open it up to any other questions from the participants. If not, we'll conclude the webinar here. Thank you very much for your time and great questions, and have a wonderful day, everyone.